MySQL is one of the most popular databases. Learn how to use it in this course from a senior database engineer.
Welcome to this basic MySQL course. I want to start by appreciating you for trying to learn a new skill. Let me introduce myself. My name is Bharat and I work for Salesforce as a senior database engineer. I have over 12 years of experience with a variety of databases, Oracle being the main one. I have experience working with companies like Chase, PayPal, Wells Fargo, StubHub, etc. Let me answer a few basic questions for you first, and that is who, what, and why. So who should take this course? This course is meant for database professionals who want to expand their skill set. If you are a software engineer or a full stack developer and you want to gain a deep understanding of MySQL database, this course is for you. And if you're a college student or a computer science student or a fresh graduate, this course will give you some knowledge on database internals. So why should you learn MySQL? MySQL is the most popular open source database, and of course PostgreSQL is definitely up there. As companies move their data from on-prem to cloud, they usually migrate to a cloud native database or an open source database like MySQL or PostgreSQL in order to save costs. So let's say that you are an Oracle database expert. If you gain knowledge on a database like MySQL, then you could help companies migrate their data from Oracle to MySQL, and that can be really valuable. Now let's look at what is being covered in this course. Now first of all, by MySQL I mean the MySQL InnoDB storage engine throughout this course, which is used behind an e-commerce website or a bank or a financial institution and so on. And MySQL offers a variety of storage engines. MyISAM, in-memory storage engine, or some popular storage engines which are available. We are going to learn about MySQL InnoDB. I am not covering any other type of storage engines. Now these are the topics that I'm going to cover in this course, and please note that this is a database administration course, so it is 80% database administration, and for people who are completely new to databases I have included SQL Basics. So you'll be learning about database installation, MySQL Workbench, database indexes, database logs. You'll also learn a little bit of performance tuning, that is SQL Explain. So these are some interesting topics that I'm going to cover. So what do you exactly need to get started with this course? You need a PC or a Mac. So if you're using a PC, then I recommend you to actually look into the worksheets or supplemental material that is attached in the description. If you have a Mac laptop, then you are in the best position to learn this course, because then you can just see what I'm typing and you can just type the same commands and just follow along from end to end. And most of all, this is the main requirement. I want you to create an AWS account. That's correct, an Amazon Web Services account. So if you don't know what I'm talking about, please do look into my worksheet, which can be found in the description. I've attached some resources which will show you how to create an AWS account. I will be using an AWS EC2 instance throughout the course, and I'll show you how to create one. But one main thing that I want you to remember is, so after each study session of yours, you can shut down your EC2 instance. That way you don't have to pay any unnecessary cost. And please do remember that you don't have to keep your EC2 instance running 24/7. So once you have created an AWS account and sign in, you will land on this dashboard or this page, and you can go to the services menu right here, and then under compute you can choose EC2. So over here on the left hand side you can choose instances, and then here we're going to create an instance which will be our lab environment. So click on launch instance, and then let's choose an image for our instance. So I'm going to choose a Red Hat Enterprise Linux version 8 64-bit, and my instance type is going to be T2 micro, which is free tier eligible, and you need to choose an appropriate subnet. If you just created an AWS account, you can just leave it whatever default subnet that shows up for you. For me, I'm going to choose maybe a specific one. And then make sure to enable this auto assign public IP option, because that will assign a public IP to your instance, using which you can SSH into your instance from your laptop. And leave all the other settings as is, and let's allocate like 25 gigs for the database or for the entire instance, and you can just leave the rest as is. Go to the next page where you can create a tag for your instance. So I'm going to call it MySQL Instance 1. Go to the security group page, and then here what's important is that you need to be able to SSH into the instance, and you need to create proper firewall rules for that. Basically anyone in the world can log into this instance via port 22, and that's not secure at all. And I will take care of this instance, because once I finish recording I usually remove it, so I know how to handle this. But when you create rules, make sure to put your laptop's IP in there, just so it's more secure. Then now you can review your configuration and then click on launch. But if you want, you can create a new key pair and then just give it some name and then download it before you create the instance. For me, I'm just going to choose an existing key pair, maybe this one, and I say acknowledge, maybe a different one. All right, this one, and launch instance. Now your instance is getting created, and it might take a couple of minutes to create this instance. Okay, that's how you create an EC2 instance. And now that my instance is up and running, and I can see the public IP, later I will be installing MySQL on this instance. So that's what I wanted to show you in this lesson. So what you're seeing is basically MySQL documentation showing all these different installation guides, like Windows and Mac and so on. So we are interested in Linux installation, or basically MySQL installation on Linux, and there's a couple of guides actually. So this one is basically installing generic binary. We're going to skip that and go here, and even within installing MySQL on Linux, there's a bunch of guides. So the recommended method of installation is using RPM packages from Oracle, but we're going to use this MySQL yum repository based installation, and it's actually quite straightforward. So for this installation, we need to go to mysql.com and downloads, and we are downloading the community edition, and go to yum repository. As you know, the instance that we created has RHEL 8, Red Hat Enterprise Linux 8 running on it, and so we need to download this RPM, but then we need to download the RPM on the instance itself, the one that we created. So let's actually log into the instance. So I'm going to use SSH, and I'm going to use my private key and log in as EC2 user, which is the default user, and basically get the public IP of my instance. And then we log in and we switch to root. Okay. So one thing that we need for downloading this RPM to this Linux instance is wget package. So let's go ahead and install that first. Alright, so now that wget is installed, we need to download the RPM that we just saw. So to get the link of this RPM, we need to go into this download, and we have to right click here and copy the link. And if you're installing on a different OS, you need to click on the appropriate button. Okay, so we got the link, and let's just go ahead and paste that link over here, like wget and the link, and that command downloads this package. Now we are going to use an RPM command to install this package. So this package, as I mentioned before, is going to add this MySQL yum repo to your local system repo list. With Red Hat Enterprise Linux installation, you get like a MySQL module by default. So let's disable that one. If you don't disable it, then this will interfere with our MySQL installation. So let's go ahead and disable it using this command. And don't worry about writing these commands. I will put a link to my Git repo with all these commands in the description. So all these have been disabled. Now let's go ahead and install MySQL Community Server Edition using yum install MySQL Community Server. And let's put the -y in there just to go ahead and accept all the prompts, and that's installing all these packages. Alright, so MySQL has been installed. Let's go ahead and start the MySQL database using systemctl command, and let's check the status. So now our MySQL database is up and running. Okay, so the log file of this MySQL database software is under var log, and then if you grep temp from this log file, you will get the temporary password for root user, and you can use that to log into the MySQL database. And how do you log in? You use this command, MySQL -u, that's going to be root, and -p is for password paste login, and then we're logging into MySQL database. So let's use this password and see if it logs in, and we are in. And if you run any command at this point, MySQL is going to ask you to reset the password using alter user statement. We can do this in a different way. So there is a executable called MySQL admin, and this is the command for it, MySQL admin -u, the username, and -p password. We are going to reset the password of root user, and let's provide the current password, which is this temporary password first, and let's provide the new password now. Alright, the password has been accepted. Now let me try to log in with this new password using the previous command, MySQL -u root and -p MySQL. Let me put the password I set just now. We are in. So let's go ahead and run a simple show databases command, which shows all the default databases that come as part of the installation. So one more thing that we need to do to complete the installation is to load a time zone file, a time zone table as shown here. So if I do a select star, which is basically a SQL query to read from this table, you can see that the table is empty right now. So let's exit out and run another command to load time zone related data. So this is the command, and let's go ahead and run it. And I'm going to go ahead and put my password, and that loads a bunch of data. You can ignore all these warnings. Let's go back to our MySQL database. So if you do a select star from MySQL.timezone again, it shows a bunch of data. So now you're good. And that completes the MySQL database installation. Alright folks, in this section we are going to talk about data modeling. Okay, so database design, data modeling, schema design, these are all interchangeable words, terms. Well, database design is an ongoing process. So you come up with a basic design when you sort of like create your application, and then as the application gets added new features, enhancements, improvements, you basically iterate over this design, right? You keep adding new things to your design and so on. So the first thing that you do when you're doing database design or data modeling is understand business data. And then once you understand business data, you have to come up with a logical design of your database. What do I mean by that? Well, basically you have to design your tables, the columns that goes into those tables, indexes, constraints like primary key constraint, unique key constraint, not null constraints, default values, foreign keys. Like these are all various things that you need to create when you come up with a logical design of your schema. Once you actually have this basic table design or schema design, then you can look for data redundancy. That is basically you see where your data is repetitive, and then you start eliminating it by normalizing your tables actually. And that's because data redundancy causes data anomalies. What I mean by that is when you have like multiple occurrences of the same data, when you're, let's say, updating certain data, you have to update in many places, and if you forget to update even one place, now you have two versions of the same data in your database, and that creates like data anomaly. Data inconsistency is along the same lines actually, and all that happens because of data redundancy. So what we are looking at is basically a spreadsheet, and a spreadsheet is basically a huge table, a large table, right? And what we are going to do is basically design a table for a e-commerce website. An e-commerce website is basically like an Amazon or eBay or whatever, like online business, like online e-commerce website like Alibaba or whatever, right? Let's say like you have only one table in this database, right? And you start, as the orders come in through this website, you start putting data into this table, right? You have let's look at some of the things that you will record in this table, right? You obviously need like a count of your orders, so you might like numbering your orders, and then how it is coming, like is it desktop or mobile, or what product is it, like here I've got like a couple of books and then book titles, and then the price of the products, and then who is the customer, customer's details, payment details, delivery details, and so on. So these are all part of like e-commerce world basically, right? And you have one giant table, and if you look at the data here, right? So here I've got like a couple of customers buying uh, you know sort of like two different products, right? So, and you can see that the data has been repetitive. What I mean by that is like every time I buy the same product, I have to repeat this data. Like the first order that came in was through the desktop website, and it was bought by Bharat, and then you can see all the details of
this customer, and all the details about the product and the payment details as well. And then the second order that came was from a different person, but then it was, the order was for the same product, and you had to repeat the product information, right? And the third was from the previous customer, but then this time he bought a different product. His information, the customer information, has repeated actually. So there is a lot of data redundancy. Data has been repetitive. So this is basically a denormalized database where you have only one table or handful of tables. We pack all the information from your website or your business into these few tables. Actually, this is a denormalized version of your database. Let's actually go look at what else you could do. So what you can do is basically you can start with this basic denormalized table, and then you can start taking out all the redundant information out of your database or your table actually, right? First thing I did was I took out like the customer information. I put it in a separate table, right? And I've got only customer details here, and I started like putting a ID number for each customer, right? Or a customer number, whatever you call it. Once I take out the customer information, I have the orders table, the initial table I'm calling orders table, looking like this now, right? And you can see that I've got like customer ID column over here. And what is this customer ID column? Your guess is right. So this customer ID column is the same as what you see over here, right? So, and why do I have that? Because I need a way to relate these rows. As you can tell, like, these are columns, these are rows. These rows I need to be able to relate to a customer, right? If I take out customer information, then how can I relate, this table and that table? It's through a common column or a bunch of columns actually. In this case, it's just one column. So customer ID, right? I'm just like putting the ID number over here. And what else actually we can take out of this table? So this is one level of normalization, right? So let's keep normalizing, which is like take out the product details, right? So product details are also repeating. So here you don't feel that much pain because there's only 3 records in this table. What if the table has million records, right? This is why we need to normalize the table. Now you actually take out the product information and move it to a different table. And then I have a product ID column just to number, like ID the products actually. And your orders table will look like this. Then you take out the payment information to a different table, and your orders table will then look like this. This is basically the process of going from a denormalized schema or a database to a normalized database. When you have your data in a single table, then you don't need to do any joins. So you might ask actually, what are joins actually? When you're running queries like using SQL, SQL is a language, right? A structured query language. When you're running commands in your database, you can get all your data from this one table if your database is totally denormalized. Whereas if you have many tables, you need to sort of combine or join these tables, and then you have to get the data out. So that is called joining the tables. So when you have a denormalized database, you don't have to do many joins, and that is kind of good in a way because your database doesn't have to think that much to get the data. You say I want this data, and this data is available in this table, so it's just very straightforward. Whereas like in a normalized database, when you join many tables, then your database engine, which they call optimizer in Oracle or in most of the databases. So this database engine has to think more, as in like, okay, which table should I scan first, and how should I filter the data in this table? And then, okay, I take the result set from that table and I have to join with these other tables. So there is so much more thinking, there is so much more processing that has to happen on whichever server this database is running on, right? And because of that, the performance will be kind of like slower, right? And it will consume a lot of resources, and you have all that happening at scale, as in like many operations are happening at the same time. Then you basically have slow performance actually, or at least slower than what it would have been in a denormalized database. But at the same time, we are removing so much data repetition, or data redundancy is very low. Because of that, the storage needed in a normalized database is much lower. So you cannot actually like generalize and say a normalized database will always be slow or denormalized database will be fast. It is all like, it depends actually. You have to look at the data and see how much repetition is happening, etc., etc. So, but generally this is how it goes. As you go through this design process, right, see what we have done actually, right? So we have decided then the tables that we need, like, we have orders table, products, customers and payments, and we decide the column names. And then not just that, for each table you need to decide actually what will be the primary key. What I mean by that is, a primary key is a unique key and which cannot be null actually, which is very important. So using this primary key, you should be able to identify any record in this table, any row in this table. For example, if I say here the primary key is order number, then I can, anytime if I have an order number, then I can look up this table. Let's say order number equals 2. I can just get this record out of my database. And then you need to also have like some unique keys actually, right? So unique keys is pretty much like primary key, and a unique key can be null. A primary key cannot be null, as I mentioned. And then you can also have indexes on your table. So indexes are ways to basically select your data faster. Let's say that I often search this table based on customer's email. Then I need an index on customer email column, right? You need to decide that, and you need to decide about which columns can be null, right? Here, none of the columns can be null. Let's say you have another column called preference, right? A customer preference, as in what kind of shipping or what kind of, or which phone number is preferred or something like that. So that can be a null column, right? So you can have null columns. Otherwise, you define your columns as not null. Let's say like in your orders table, you have this delivered column. When an order is basically created, when a customer buys a product on your website, of course it's not delivered immediately. At the time of order creation, the delivered column will always have no or n value, right? All these things, all these decisions that we are making, we're talking about, is part of schema design. And once you have all this figured out, you can put the information in a ER design tool, entity relationship design tool. And in the next section, I will show you how I do that on SQL Workbench, MySQL Workbench basically. You can actually then have a pictorial representation of your logical design of your database, right? And that's basically what you call an ER diagram. And of course, you can talk about the relationship between like two tables. Let's say you can say, oh, this table and this table, they have one-to-many relationship. For example, each customer can place many orders. So that is actually a one-to-many relationship, right? But one order can be done by only one customer, right? So that kind of thing. So you have one-to-one relationship, one-to-many relationship, or many-to-many relationship between tables actually. These are all part of data modeling. But you don't need to be worried so much about that, as long as you have clear idea of like what data is coming into your database. And along the way, you need to define like the data type of your columns actually. That is very important. Your names are going to be a varchar, phone numbers can be numbers, and then email is again like a varchar, and your ID column or number columns are going to be int or number. these are all some decisions that you would make in a data modeling task. Actually, that's pretty much what I want to say about data modeling. And there's much more we can talk about it, and like atomicity, like you have all the address sort of like attributes packed into one column. We need to split that as well, so that is called atomicity. You can have address separately, city separately, state separately, and zip code separately, right? So those kinds of things. There are nuances that make your database more and more efficient, and of course we're not going to go into a lot of details there, but this is the basic data modeling that you need to understand. And as I said before, in the next section I will show you how to take this and then input that on MySQL Workbench. A quick recap of what I did in the last section. I basically created a logical design of an e-commerce website. So what you're looking at is a table that I started with. It's a denormalized table, and we basically took this denormalized table and we normalized it. As you can see, there is 4 versions of this table. I'm calling this table orders table. So there is 4 different versions, and with each iteration I took out repeating data. So finally we landed with 4 tables apart from the original orders table. So now we have also customers, products, and payments. In this video I'm going to take this, all these tables, and then I'm going to take the structure and I'm going to create a logical design. Okay, so let's actually go to MySQL Workbench, and I am already connected to a database. What I am going to do is go to File and go to New Model. So here we can add a new ER diagram, an entity relationship diagram, and let's call this database ecom store, something like that. So let's go ahead and start creating our tables. Now I'm not going to be creating all 4 tables. That would take probably more time or long, and I'm going to be creating a couple of tables, and that should be enough for you to understand how we're doing this. So let's just start with the customers table. So the customer table has 5 columns. So this is the icon for creating a new table. You can drag and drop, or you can try to draw, and now double click and then create a table called customer. And here we can start putting the column names, customer ID, and then this is going to be populated by a sequence. So sequence is a database object, and it's going to be an integer, so we can leave it as is, and we can have it as a primary key. That's fine, and a primary key has to be populated. It cannot be null, so that is automatically selected. So the next one is customer name. We could split that into first name, and then we can choose varchar and maybe give a little bit more room, as in the length for the name, and then last name again varchar 100, and then all these cannot be null, so we can choose not null constraint. So these are different constraints which are available. Let's go ahead with the next one. Address, again address, and if you remember I talked about atomicity. So you want your columns to be, atomic in the sense that here basically the whole address is packed into one column. Good practice to actually split that into atomic columns, as in address separately, city separately, state separately, and then zip code separately. So we have all these, and of course none of these can be null. And what else is there? So customer phone number is going to be all numbers, but then I want to make it 10 numbers, of course not null. And customer email, so we can just say email ID 100, make it not null. So since ID is the primary key here, or customer ID, I want to make sure that we have a constraint to avoid repeating customer information. For example, if you have one customer's data for ID 1, I don't want the same customer's data to repeat for a different ID, for example ID 2. So I'm going to actually make the email ID unique for each record over here, and then maybe phone number also. So these are all unique key constraints or unique constraints. That's it. So we have the customers table created. So let's go back and see what else we have. So let's now create I would say product, and then you basically do the same thing. Select that, which is for creating a new table, and then now here you can just draw, and this one I'm going to call it product. Then we want to go through the same process and then put the product column names in there. And if you're wondering, this is the same customer ID column that we added over here, and we are going to make that a foreign key in a minute. So let's go ahead and split that into multiple columns, because again everything is packed into one column, which is not a good practice. So let's call it credit card number. If the customer is using PayPal, then we need an email, so we can use email ID over here. So this can be null or not null based on what payment type is being used, so that's okay. So expiration date is going to be a date column, so let's actually change that. So if you're not sure, you can hit that the drop down and then choose a proper data type for each. The other thing that I mentioned, which is basically about foreign key, this customer ID is the same as what we added over here. So let's actually make that customer ID a foreign key. So we can just call it customer ID foreign key 1, and then the table that is going to be referenced is the customers, and the column is going to be customer ID. And that's it. So you can see that now we have a connection or a relation between these two tables. I'm going to actually just add the orders table as well. I've created the orders table as well, which is the main table, and I'm going to now create some foreign keys for the orders. Everything is done. If you want to create any indexes at this point, you can do that. So I guess we're done. So we basically added 4 tables to our logical design, these 4 tables, and then we have created columns and then defined their data types, and also we created the foreign keys, and of course primary key and unique key for each of the tables, and you can see the foreign key relationship, clearly showing here. And that's that's what you would do to create a data model. All right, so now actually let's just go ahead and create a SQL script for this data model. So you go to database and then do forward engineer, and then basically you provide the database details where you want to create these tables or the schema. So these are my details. Continue. Let's go to the next one. Provide the password. All right, now we are connected. I had to try the password 2-3 times. All right, and this has basically created a SQL script for us to create the schema and the tables with all the primary key, unique key, and foreign key constraints. So what we can do is we can just continue, and then now the database or the schema is created as it goes through and then executes that script, and close. And now you can see these tables are actually created. So you can even go to your SQL editor and then you can start querying your tables. There you go. So the query came back. Of course, there is no data in it, and you can now start using your database. So we actually successfully created the basic schema or designed the data model for this e-commerce website. A table creation or a create table command starts with create table keyword followed by the name of the table and followed by parenthesis. So within the parenthesis, this pair of parentheses, you have all these column names followed by the column data types and followed by the constraints, and you can also use this auto increment keyword if you want your column value to be incremented automatically as you load records to this table. And after the column definition, you have the option of specifying the keys like primary keys, unique keys, foreign keys, and so on. You can also specify the storage engine type as part of your table creation. And this is a very simple table. You can also have partition tables, subpartition tables, you can have compressed tables, encrypted tables, and all these things require special keywords to be used in your table definition. And please check MySQL documentation if you want more details about the syntax. As mentioned, I'm using just integer varchar data types. The MySQL documentation shows like all these different data types like numeric, date and time data types, string data types like the ones I'm using, and JSON, spatial. So these are all available in MySQL for you to use. So let's go ahead and create this table, and before creating the table I want to run this drop command just to make sure the table doesn't exist, and then I'm going to be creating the table. And let's see if the table's been created. Yes, the table's been created successfully. I'm going to be running a select star from the table name to see if I can successfully query from this table as well. And then it returns basically it doesn't return anything. That means no data exists in this table. And that's how you create a table using create table syntax. Finally, there's actually a default keyword which helps you specify default values for a certain or for your columns. So if you don't specify a value for this quantity column in your insert statements or when you're loading data through procedures, it will automatically take this default value. That's pretty much it. And I'll see you guys in my next MySQL SQL session. So I just did a describe on the table that I created, and it has product ID, product name, product type,
price, and quantity. And you can see that product ID is also an auto incrementing column. Right now there is no data in it. A typical insert statement looks like this. It's got the insert into keyword and the table name, a bunch of columns within parentheses, the ones that you want to populate, followed by the values keyword, and followed by the actual column values. If you can realize, I haven't actually specified the product ID value because it's an auto incrementing column. So let's go ahead and execute this, and the insert statement goes through. So let me also run the select statement. As you can see, the product ID table has taken the value 1, and that's happened automatically. I didn't supply the value 1. So I'll go ahead and commit the change, and then let's actually move on to the second variation. So this time I'm going to specify a value for product ID. Nothing else is different. So just want to show you that it is possible. So it goes through, and then a commit, and then let's do a select to make sure the value has been inserted. So let's go to the third variation of this insert statement. So it's going to be pretty much the same, except actually I'm going to just jump some values and then insert the value 10 for this product ID column. I'll go ahead and do that. It goes through, a commit, and select again. Then you can see that that is also fine. So yeah, so that worked. So you can actually jump a few values. Let's actually look at the next variation. Again, I'm going to insert a record into this table with no product ID specified exclusively or explicitly. The product ID column is missing over here, and I'm going to run the insert statement and a commit, and then I'm going to run the select statement. So I just wanted to show you that wherever the latest value is for this auto incrementing column, I inserted the value 10 for product ID last time, and then the next time I do an insert, this auto increment kicks in, and then increases this value from 10 to 11. So it picks up from the value that was inserted last time. And I'm going to just take another insert statement, and this time it's actually insert into the table name, and instead of the values keyword specifying the column names, values, etc., we actually select from a different table. Basically, if the products 3 table is exactly matching the structure of products 1 table, then we can do even a select star from. If the columns don't match exactly, as in like products 1 has a different set of columns and product 3 has a different set of columns, then we need to make sure that we actually select the columns, and then, for example, this product ID from products 3 maps to this product ID in products 1, and product name from products 3 maps to product 1 in product name in product 1, and so on. Let's go ahead and run this and see what happens. And then that goes through, and then if I now select the products 1 table, you can see like all these rows are inserted properly, and basically the products 1 table is populated, and then we got all the data from products 3 table. So this time I want to show you the insert statement again. This is kind of like a bulk insert or a multiple insert just combined into one statement. You can see the insert into clause is specified only once, but in the values part in this clause actually we have 2 rows specified at the same time, so we can even use such a syntax. And a commit, and then do a select. All good. So these are a few variations of insert statement. I hope you understood how this works. I'll see you guys in the next session. Hey MySQL learners, so in this session actually I'm going to be talking about update and delete statements. So as usual, I'm going to be using my ecom store schema, and I will be using my products table to do this demo. So just quickly, if we select products table, there's 2 rows right now. So the first update is just to show you the syntax of updates. So you have the update keyword followed by the table name followed by
set keyword, and then you can have as many columns as your table contains, but in this case I've got only one column, and I can just run this update. So let's actually add one more clause to it, which is the where clause, and this is to just update the rows that you really want to update. So we will be updating only the rows with product ID equals 1. So let's go ahead and do that, and then I'll just commit and do a select from products. Quantity has gone up by 50. It went from 299 to 349. Now one more thing to realize is actually, like, you can specify literal values when you're updating. That happens all the time. Or you can also like specify formula. You can have SQL functions like replace, substring, length, and so on. You can look at MySQL documentation to see what kind of functions are available. In this update, like, I just wanted to show you the syntax, basically to let you know that like you can have multiple, you can update multiple rows at once. In this case, I put like the values 1, 2, and 3. You don't have to do one row at a time or anything. So when you use the in keyword, then you can say product ID or whatever column in, and then a bunch of values to select the rows that you want. And there are other ways to do it, but the point being, you can update multiple records at once. And another interesting usage is using the case statement. You can, let's say you have a bunch of update statements, one for product ID equals 1, another for product ID equals 2, and another for the other product ID values. Then you can combine all that into one update statement using a case, when, then, end clause or keyword basically. In this case, actually, for product ID equals 1, I want to increment the quantity by 50, and product ID equals 2, I want to increment the quantity by 100, and so on. So then I've got this a similar where clause that similar to the one that I showed you before. I'm going to run this. You can see the columns are getting incremented. I'm not going to go back and check. I'm pretty sure that it's done the right thing. So the next one is basically when you want to delete records from a table or purge data from a table, then you can just use a simple delete statement. And if you are wanting to delete a particular row, again similar to the update, you can use a where clause to actually like narrow down the data that you want to delete. This particular statement, which is delete from a table name, and then where column name equals the column value, and you can have multiple filters in here. So here I don't have the row number 3. I think I deleted it already. All right, so let's keep going. Products 3 table, I just wanted to show you, it contains a lot more data than my other table. You can see it contains data about 5,849 rows. I wanted to also show you this particular parameter, MySQL configuration parameter, to basically enable and disable safe updates. So let's say like if your delete statement or update statement is not using a primary key column in the where clause, then basically if you enable this particular parameter, let's say by setting this 1, and then if you run your delete, you will get like an error code 1175. It means and then it says you're using safe update mode, etc., etc. It's not letting you to run this kind of delete statements because it could be it could cause bad performance. So if I disable the same thing, and then if I run the delete statement and then just run a select again, then it should go through, because now the parameter is disabled. And two more things. One is actually like if you have a huge table and you want to delete only a few rows at a time, then you can use the limit keyword to limit the number of records that are deleted by this statement. In this case, like I wanted to delete only 10 rows. Let's go ahead and do that, and it should just work just fine. And then if I do a select, you will see the difference in the row count. Actually now it's like 5839, before it was 5849. So that's how the limit clause helps you. Also in the limit clause, you can all specify the order by clause. It basically sorts the data by these columns, like first by quantity, then by product ID, then it deletes the top 10 or 100 or whatever value you put here actually. So let's go ahead and do it, and then select again. Yeah, 2070 is gone. So the top 10 rows are gone, and yeah, that's pretty much it. Actually, those are all a few variations of update and delete statements, and of course there's lots of tangents we can get into, but I will leave that task to you. And I hope it was useful, and if you have any questions, let me know in the comments. I'll see you guys in the next session. Hey MySQL learners. So in this session, we'll look at select statements, not just the syntax, but also like some ways you can actually like improve the performance of your queries. I'm going to be using the schema called ecom store to explain about this. A select statement in its most simple form will look like this. So you have the select and from keywords, and then after the select, you specify the select list, which is the columns that you want to select. If you specify a star or asterisk, so that actually selects all the columns from this table. And then after the from keyword, you specify the table names where you want to select the data from. So if I do a select star from products_3, it's going to return all the data from products_3 table. But do remember that anytime you are using a star after the select or in the select list, you are basically querying all the columns in this table. You don't need to query all the columns in the table in most other cases. So you only like specify the columns that you need to query. So in this next query, let's go line by line and see what changes that I've done to this query to make it better. So let's say I want to select only these columns. That's why I specified only these columns in the select list. In the from clause, I have specified products_3 table. Very often you will be selecting from multiple tables. You need to join the tables and then retrieve useful data out of it. And in the where clause, you specify all the filters, all the conditions based on which your data will be filtered out. So here I am including only the data which have quantity less than 25. So this way I'm able to actually filter most of the data out of this table. This is very useful in minimizing the amount of data that you retrieve from the database. Hence, your queries are going to be fast. This order by is basically going to sort the data that is retrieved based on the columns that we specify here. So here, I'm just like ordering by product name. And of course, like when you're sorting data, especially when you're sorting a lot of data, the operation can be expensive. Unless your sort buffer size, that is actually the memory area where the sorts happen, unless it is sized properly, the operation can be really slow. So you need to pay attention to that configuration as well. And I have this other query which just goes to show you that like this is a very simple select statement. Again, in this select actually I have only the select keyword and a function. I'm using the now function, but there are several other SQL functions that you can use in this query. For example, I can use the database function to return the database that I am actually connected to. And as you can see, I am actually able to invoke multiple functions in the same query. So that's pretty much it. I'll see you guys in the next session. In this session, I will be teaching about SQL Joins. Let's dive straight into the demo. I will be using a schema called ecom store, and I'm creating a table first called T1 with one column. The column name is C1, and I'm inserting these two values in this table, 1 and 2. I'm creating another table called T2 with a column called C1. I'm inserting these two values again into table T2, 1 and 3. So it's 1 and 2 here and 1 and 3 here. I'm going to go ahead and run a commit to make my changes permanent. So I'm going to be just querying these two tables just to show you the records. T1 has 1 and 2, T2 has 1 and 3. Of course, a join is an operation that joins two tables, and we have all these different types of joins. We'll go one by one and understand what they are. So this is the syntax. So select a column list that you're selecting. So we're joining T1 and T2, and then we are specifying the kind of join that we are making. And then we also have this on keyword, and then comes the condition on which the table is joined. So I'm going to go ahead and run this query and see what happens. As you can see, this query, this inner join has returned the value 1. So that means actually, so it returns the values that exist in both the tables that match. So that's what inner join does. So let's just change it to a left join. Go ahead and run it. Now the left join is going to return all the values from your left table, which is T1. So T1 has values 1 and 2, or the rows 1 and 2, and then T2, it's going to return only the matching values, and then for this value which only exists in table T1, it's going to return a null. And then I'm going to change it to right join, and as you might have guessed, it's going to return all the values from table T2. In the places where there is no matching value, it's going to return a null. So let's see if that happens. That's what we expected. So we got all the rows from T2, and then for 3 there is no matching value in T1. That position has null value. Now we'll jump quickly to a union, and then we'll come back to a full join. A union is basically gonna look like this. So 2 queries, and then in between we have the union keyword. Let's see what it returns. You can see that it's returned 1, 2, and 3. So that's actually the rows from both the tables, but it's kind of like combined the data and then smushes them together, and then you have 1, 2, and 3. And then let's run the same query with a slight difference. We'll put union all, and then we'll see what happens. And that's returned 1, 2, and 1, 3. So that's returned all the data from both the tables, but except this time we have duplicate values. So a union gets rid of all the duplicate values. It's almost like a set where you have a unique set of data. A union all returns all the values including duplicate data. Jumping back to full join, we don't have a full join keyword. So rather we do full join this way in MySQL. So basically you have a similar query where you're joining T1 and T2, a left join first on this one column that we have, and then you have another query again joining T1 and T2 on this one column, but then we are doing a union of these two, and that's going to return the data from both the tables. We have 1, 2, these two are matching. Then for 2 there is no matching value, so it returns a null. For 3 there is no matching value in T1, it returns a null over here. So this is a full join. That's basically all the joins, all different types of joins that you can do in MySQL. I hope this example was clear, and I'll see you guys in my next session. Alright, MySQL learners, in this section we're going to learn about locks. More specifically, I want to talk about the isolation levels actually. So the first thing is just see what I have here. I have like 2 terminal sessions. One is in black, the other one is in slight maroon color. So I am actually going to log into the database as root user, and I'm going to do the same thing over here. There you go. I am logged into MySQL database. So I have a little script here to create a dummy table called T1. Okay, so let me show you the SQL script. So at this point, actually, you might not understand the SQL syntax and so on, but then let me explain briefly. First thing I'm doing is setting auto commit to 0, or commit is basically a command that you use to save your work. Basically the data changes that you're doing is permanently stored in the database when you issue a commit command. In MySQL, you have this variable called auto commit, which is turned on by default, meaning all your commands will be automatically committed if you don't turn this off. I want to have more control over what I'm doing here, so basically I am doing an auto commit disable first. So and then I'm starting a transaction, and just to be safe, I'm dropping this table if I had already created it. So this table doesn't exist, so it says unknown table. And the next thing is I'm creating a table called T1 in ecom store schema, and then the column name is C1, and the data type is int, and it's a primary key. So and then I'm actually inserting a value, just one row, into this table called T1, right, the one that we just created, and I issue a commit command. Alternative to commit is a rollback command, so which basically rolls back
or reverts the changes that you just done in that session. So if I just do a select star from this table, then I'm going to see this value, so which is fine so far. So this is pretty straightforward. So far we haven't talked about the isolation levels. So what I mean by isolation level is when multiple sessions are trying to modify or access the same data, then you need locking mechanism to make sure the data is not corrupted or the database is behaving in a way that you expect. To see how you actually set isolation levels, and this is the command. So this is the other session I had open. Show session variables like isolation. So that shows like the transaction isolation level is set to read committed, right? So this is one of the possible options actually. So this is read committed, and you have read uncommitted, and you have repetitive read or repeatable read, and then you have a serializable value actually. So let's go one by one, right? In this session, I already started a transaction, so I'm going to actually try to update this value using an update command. So basically I am updating the same table, and I'm updating this column to 2 where the column value is currently 1, right? So I'm going to do that. The auto commit is turned off, so it's not committed yet. I'm going to start a transaction over here, and let me run a query against the same table, and just copy and paste the table name. Don't want to type it. Okay, so we see the value 1, which is the previous value. And if I ran the same query over here in this session, I see the value 2, because this is the session where we are modifying the data, right? So, and I can see the changes before committing in the same session. Here actually, since the value of this transaction isolation or the isolation level is set to read committed, it is possible only to read the committed data. In other words, when multiple sessions are accessing the same data, in this case this column right here from this table, apart from the session that is actually modifying the data, the other sessions can only see committed data. Any data that is committed just before this select is executed. So I'm going to go here and run a commit and come back over here and run a select. So now you see the latest data because that commit happened before I ran this query. Now let's talk about read uncommitted isolation setting actually. Freshly log in again because these things can get tricky. So every time I want to just recreate the tables to remove any confusion. So let's actually log in again. Okay, in here, and I'm actually going to execute the same script that I showed you before. So just disabling auto commit, starting a transaction, dropping this table, recreating it, inserting this value, and then running a commit. So now here, what we could do is go ahead and update this value to 2. But remember, I haven't committed this data yet. Let's go to this session, and here go ahead and change the setting to the isolation setting to read uncommitted, because by default it is always set to read committed actually, right? So you can see that here. So, and this is a session level setting, and you can also change it at global level, but for the purpose of this demo we just need to change it at the session level. So session level isolation, initially read committed, then I ran the set session transaction isolation level, read uncommitted, and then checking the value again. Now it's changed to read uncommitted. If I ran a select star from this table, then I get the value 2. And if you remember that I only updated the value from 1 to 2, and you can already see this data
even though it is not committed over here. So that is how read uncommitted works. So there is not much locking going on here because database is now letting these sessions do dirty reads, because one session is able to read another session's changes even before the commits happen actually, right? So those are dirty reads. Yes, actually. So let's go on to the next one. So we have seen read committed and read uncommitted so far. So now let's move on to repeatable reads actually, right? So exit. So here I am going to just commit, and I'm going to rerun my initial script just to clear the table. So drop table and then recreate it, insert value 1 again, and then commit. So now the table is back to how it looked before. So here, let me log in again. So this is repeatable read setting, right? So remember that the default value for this isolation setting is always read committed. So if I change it to repeatable read, right, and then check the value again, then you can see this. So, and again, remember our show variables is the command to check the current value, and then set is the command to set the configuration, right? So I will put all these commands in like a GitHub repo file. Then you can actually grab the commands from there, and then you can try them yourself. Basically, I'm changing the setting from read committed to repeatable read, right? So I'm going to just start a new transaction over here. In here, I'm going to update this value to 2, and over here I'm going to run the select query that we saw before, just selecting everything from this table. And you see that the value is currently 1, and that makes sense. So let me go ahead and run commit, and if I run the same query again, I see the value 1, and this is the same as the value that was read before. Even though the data was changed by this other session and then committed within this transaction, the data that we are seeing is the same. In other terms, basically we are reading the same data, or the reads are being repeated, right? So that is the third setting, and the last one is the most strict locking configuration, so which is called serializable. So I'm going to as usual, I'm going to drop the table and then just recreate them. Recreated, inserted value 1 again, and then I commit. So here I'm going to log in again, and as usual, the default setting is read committed, right? So let's check that first just to show you, and then I'm going to change it to serializable. So what this means is basically I'm going to start a transaction. So on the first session, I'm going to run an update, basically changing the value from 1 to 2, and here I'm going to start a transaction, and I'm going to run a query on that table, right? And now this query, even though it's just a select is just a read. It's not updating, it's not deleting or doing anything. It's just a read. It is waiting because the update is basically updating this data, and then it's not database, MySQL database is not even letting this read or the select query from the other session to see the data. So this is the most strict setting actually. So if I do a commit over here, then on this other session you will see that the query has written and it's seeing the latest value, right? So if I go ahead and run another select, of course it's returning the same thing, but if I try to update this value from 2 to 3, another update, that is basically going to wait on the select, basically this transaction
that is running right now, because the select, again, select is just a read. It is just reading the data, but still it is locking that row in the database, and it's not letting any updates or modifications to that data. And then you can see that the update even failed because it waited for some time and then the timeout value exceeded. So we don't have to go into those details, but I'm going to try updating now. And here I am just going to exit out of this session, which will release all the logs, and that will help the update to go through. And then I can commit and exit as well. And I hope it was clear to you guys. And if you have any questions, please put it in the comments and reach out to me somehow. I know you can figure out. I'll see you guys in the next section. Hey MySQL learners, so welcome back to this new section of my MySQL tutorial. So in this video, or in this section, we're going to talk about logs. So what are these logs, right? So let's actually approach this kind of like logically. So if you have a database and if you're the only person working in this database, then you basically need not worry about anything, right? You know what you're doing, so you will insert data, delete, update data the way you want, and there is no one else trying to intervene or interrupt your work. But unfortunately, that's not the case in today's world. If you think of a busy e-commerce database like Amazon, then there's like a lot going on those websites. There's like multiple people browsing. There's like a lot of people buying stuff. There's the people who are selling stuff on these websites. They're updating data relevant to their products. So that is basically concurrency, right? So you have many users trying to do something on this website at the same time. So how do you manage this concurrency? That's why we need logs. So if I let everyone work on the same data at the same time, then there's going to be a lot of confusion and we might end up losing some data. So let me actually show you a simple example of how that happens. So I have a table, a product table. So if you've been following my tutorial thus far, we talked about this table called products. So where we store all the product information, right? So now there's a couple of records over here, and let's say that we have a seller and a buyer who are working on these records, especially like this particular record, the first one, which is a book, and the book's price is this, and the quantity, I think we didn't have quantity when we talked about it in my previous sections, but then I added quantity here. So there's this quantity column, and there's a seller and buyer interested in this record. Let's look at this, right? So we have sort of like a time sequence here. So what the seller of this particular product is trying to do is he's trying to update the quantity of this product. At 9/1 he is adding 60 more quantity to that product, which is 40 plus 60, which 100, and that's what we have over here. So then a buyer comes and he looks at the quantity, and then he basically wants to order 2 of these books. That's 100 minus 90, 100 minus 2, that's 98, and then you have the quantity 98 over here. So this happened in a sequence. So but we are worried about concurrency, right? Concurrency is like when things happen at the same time. But what if, okay, first the seller comes and then he reads the quantity of this item. Initially it was 40, and then buyer comes and he also sees that the quantity is 40, right? And at 9:01, So the first two operations happen at the same time. At 9:01, seller comes and he says, I want to update, I want to add 60 more quantity, like meaning I have 60 more books of this title. But then buyer comes and he says, okay, I'm buying two items or two of these books. So, but the value that he saw before was 40. So 40 minus 2 is 38. So he updates the quantity to 38. So the seller updates it to 100, but then because of this previous lookup, the quantity is updated to 38, due to which this whole thing, this whole operation is lost, and we end up with sort of like corrupted data for this quantity column. So this is a simple example of how concurrency, when not managed well, might cause data issues like this. Hey MySQL learners, so in this video we are going to look at basically how table locks works in the context of e-commerce database. We created a simple database or schema called ecom store, and we created a bunch of tables. I used another dummy table to explain transaction isolation levels. So if you haven't seen my previous material, go back and check it out and come back here. But then yeah, you have four main tables, and the main table that we are interested in is products table here. And in the products table I inserted a couple of records. These are dummy records, so I don't have a front end or application running over here, so we're just looking at database, right? So what's going to happen in this tutorial is so we're going to basically simulate a situation where a seller is trying to update the quantity of the book that he is selling on this website, which is this first book, actually, The Common Path to Uncommon Success. And then right now the quantity available for this book is 40, right? So he wants to update this quantity to 100, and also we'll have a couple of more users or buyers. Basically, one buyer is trying to buy the same book. We'll have another buyer, he'll try to buy a different book, which is this book, Tiny Habits. And then the same buyer will also try to browse the website. Like, of course, like, we are going to have to imagine a little bit, because I don't have a front end to show you everything. So let's actually see how this goes. So first of all, basics first. Actually, let's actually turn off the auto commit, just so actually we have more control over what's happening. And let me do that in all the three sessions I have open. And the first session is the seller session, the second session is the buyer 1 session, and the third session is the buyer 2 session, basically. So I'm going to turn off the auto commit, which is basically a mechanism that commits automatically if it's enabled, and I don't want that, so I'm disabling it. So next is I want to show you the transaction isolation level, and we talked about it in my previous session. So right now it's a repeatable read, and it's the same for all. So we are going to change that to read committed, because read committed is the right isolation level for OLTP databases. So now let's actually start with the first seller session. So 3 sessions. So the first seller session is going to update the quantity of this book.
that he's interested in, or he's selling actually. But we are going to take this aggressive approach and log the whole table, right? So let's say the application is written in a way that it logs the whole products table for write. And then the other session, let's say buyer 1, the second session, buyer 1 comes and he is going to try to buy 2 books. And how actually we're going to do that is by running an update. So we are basically updating the products table and we are subtracting the quantity by 2, which means actually we are buying 2 books. And which book is it? The book where the record where product ID equals 1, right? So if you remember the data, product ID 1 is this book. Let's go ahead and run this update in the second session, and it's going to obviously wait because the table itself has been logged for write by the seller session. The buyer 1 session is waiting, and let's go to the buyer 2 session. The buyer 2 is trying to buy a different book. Which book is it? This other book, which is Tiny Habits book, where product ID equals 2. And we're going to do that. And of course, even that is hanging or waiting. And that is actually a little bit crazy, isn't it? So if just seller is trying to update the quantity of this one record with this one book, and everything is hanging, and the buyer 2 who's trying to buy a different book, he kind of gives up, so he moves to a different session, and instead of buying or trying to buy a book, he just tries to browse the website, which is a select query or a read query, right? A select query, which is also hanging. So the buyer 2 is getting frustrated right now. So you can see how restricted this kind of sequence is. So if someone's using table logs, it's going to basically reduce the concurrency of the operations that can happen in this database. So that's the main point here in this demo. Hey MySQL learners. So in this session, we are going to take a brief look at row level logs in MySQL. I have 3 sessions. I'm already connected to my e-commerce database, MySQL database, and this is how the data looks now. So we have a products table which holds this data, only 2 books now, just dummy data that I created, and this is the price, and you have the quantity column showing you how much quantity is left for each of these books. So the first session is seller session. The second session is buyer session. We can call this buyer 1 session, and the third session is a buyer 2 session. So this is the data, and just for clarity, actually I wanted to show you the transaction isolation setting, which is read committed, and the auto commit is turned off. Basically it's disabled. So unless I commit explicitly, my transactions will not be permanent. So let's actually start with a seller. He's going on the website or a portal that he has available to update the inventory of, let's say, the book 1, right, or the product 1, which is this book. And so he's going to click some buttons, which is going to translate to an update statement being executed in this database, right? So let's say he wants to increase the number of books available in the inventory. So that will mean quantity is going to be incremented by 50. So that's the update statement, and he's going to run that update, and we can look at the buyer 1 session. Let's say buyer 1 is trying to buy the same book, and then so he's going to go on the website and then click on buy now or whatever, and that is going to translate into this update statement in the database, which is quantity equals quantity minus 1. So reducing the quantity by 1, meaning he's buying a book. And of course there's going to be, you know, other statements updating other tables, but then to keep it simple, I'm just showing you the products table changes section. So as you can see, this is going to wait because seller is updating this particular row actually, and that can be seen using a query on Deadlocks. So if you run the this query, of course you can modify this query as per your needs, but then if you query this, you will see that there's a bunch of sessions, and here's the lock mode column, and then the table on which, or the database on which the locks are happening, the table. So it gives you a lot of details. So if you want to understand what's going on here, so we have products table, and then we have IX lock, which is intention exclusive lock on the table itself, meaning like a transaction is about to get an exclusive lock, and this is at the table level, but don't get tricked by that. There's also another row indicating there is a record level or a row level lock, and that is locking only this data equals 1. So if you remember our update statement, we are using product ID, so, and the data for which is 1 actually. So product ID equals 1. So that's what we are seeing over here. And if you see here, this buyer session has actually timed out already, so he's going to attempt to buy again. So that's how like you can actually look at the locking details in this table. Let's say like buyer 2 comes in at this point, and then he just tries to browse the inventory on this e-commerce website. So that would mean a select query, a read query, and he's able to do this happily actually, right? So there is no problem. So while the row logs are happening, other sessions can read this table. They can even look at the data for the same product, but they just cannot buy this book because that is being locked by the seller. So again, it timed out. So at this point, buyer 2 wants to buy a different book. You know, I'm not able to buy this book, let me try buying a different book. That's going to translate to you know, product ID equals 2, which is not being locked by the seller, and then that update goes through. And at this point, let's say the seller has completed updating the inventory, and of course if you look at the data now, it's going to look different because this has been updated to 150, and of course this hasn't gone down because buyer 1 is still in the process of buying the book because the commit has not happened yet in the application. And then if we look at the data again, the data has gone down, or the quantity has gone down, and then buyer 2, let's say, wants to buy the first book that buyer 1 wanted to buy. At this point there are no locks in this table because everyone's committed, and let's say buyer 2 is trying to buy this book, and then he goes through with the update and then commits, and look at data, and then the data is changing actually. So this is how a row level lock basically allows for high concurrency. So only the rows which are locked by your transactions are not available for these other sections to modify, right? So the other records which are not touched by your transactions are available for updating, deleting, etc. And all, of course, you can add new books. That means inserting new records in this table. So I just wanted to show you the difference between table level logs and row level logs. So this session and my previous session will be useful in understanding that difference. Thank you. I'll see you in my next session. In this session, we're going to be talking about deadlocks, and I just want to show you how deadlocks happen. They do happen in a busy e-commerce OLTP database often, so it's good to know what they are. So, and it's going to be a very short and sweet session. So here we have a couple of sessions again. So connected to the same database. There's two sessions, two different sessions. So let's say that we are working with products table, right? So we have seen this table before in my previous sessions. Basically, this table has information about the products that are being sold on an e-commerce website. So we have a couple of records over here. We're going to first let's say a seller comes to actually update the quantity of this product. Basically, let's say if he wants to increase the quantity by 25 for this first book, this is the command that he's that's going to be executed. Whatever buttons he's clicking will be translated to an update command like this, right? And let's say like a different person from the same company wants to update the price of this book. Not this book, let's say we have the other book. I'm just actually using the product ID to update the right product, right? So we have one session where seller 1 is updating the quantity of this item. We have another session where we are updating the price of this item, and then if you see the price is incremented by 2, let's say $2, and this is fine, right? So now we have row level locks. So this guy is holding a row level lock on this row, and this guy is holding a row level lock on this row. So this is fine, right? So we are operating on two different records, two different locks, independent of each other, all good. So now let's say the same seller, the second person who is updating the price, wants to update the price of this other book too. Actually, like he is actually increasing the price again by $2 of this book. The product ID equals 1. Which book? This one right here. Let's go ahead and try to increment the price by running this command. He's waiting for the lock, actually exclusive lock, and that's not available because this seller has not committed. Actually, is not committed. So let's actually go back here, and this seller at the same time tries to update the price of or quantity of this book. So two sessions are fighting for pretty much the same resource. We ended up in a deadlock situation. So MySQL was smart enough to just kill this session. Otherwise, we would have two sessions waiting for each other endlessly, right? So here you can see the error code that is thrown.
It says deadlock found when trying to get lock and try restarting the transaction. So let's go ahead and query the products table and see how it looks. You can see that this whole transaction was rolled back, correct? Both the transactions were rolled back. Even this one was rolled back. So I think that lock was also killed. So that's why this one went through. And if you can see, the prices have increased by $2, like, because initially it was $16.99 and $20.39, and here $18.99 and $22.39. Okay, so that's how it works. Okay, this is a typical deadlock situation. I hope this explanation was clear, and I will see you guys in my next session. All right, MySQL learners. So in this session, we are going to talk about clustered indexes. So clustered index is not a different index type, as in like you can directly create a clustered index yourself. So it is a type of index that that MySQL kind of maintains in the behind the scenes actually. So, and also your table data, the data that you insert into your tables or load into your tables, are maintained in these uh, indexes only. What I mean by that is, so let's say this is a B tree index, right? So this is a B tree index. So you have MySQL creating this B tree index as you load data into these tables, and then in the leaf nodes, what you have is actually the data that you're loading into these tables, right? The clustering, the sorting is based on the primary key that you define on in this table actually. So if you don't define a primary key, MySQL will automatically pick up a non-nullable index key. What that means is, so let's say that in fact, actually, let's jump straight into the example that I have prepared for you guys. So this is my MySQL workbench, and I'll show you this table definition. So this is called products underscore one, and it's basically a products table that is typically used in a e-commerce store. And if you've been following my lessons, this is what I've been using. I just changed the name of the table for demonstrating this concept, this clustered index concept. So you have all these like columns, and I'm defining a primary key. Okay, so let's just start by I'm just going to switch to a database called ecom store, or schema called ecom store. I'm going to drop these tables if they exist already by any chance. So the table doesn't exist, which is okay. So I'm going to create this table which I just talked about called products, and then this table has primary key primary key as product ID. So product ID is sort of like an integer column. So this is an auto increment, right? So you don't even have to provide a value for this column actually when you load the data. So you can just put all this information and load it, and then we are good. MySQL will automatically increment the value of this column actually. So, and then of course, like I said, like there is a ISBN column which is over here. It's sort of like book ISBN information. If you are if you remember your school days, like there is this ISBN number attached with any book, so something like that. So some kind of ISBN alphanumeric number. So I'm going to call that like a unique key or a unique constraint. And let's go ahead and create this table and this constraint. So that was successfully created, and I'm going to create a procedure which I can use to kind of like populate this table, right? So don't worry about the details of this procedure. This is something that I wrote to populate this table, and then that
is successfully created, and change the delimiter back to a semicolon. And then I'm going to call this procedure, and which is going to throw some warnings, which is okay with me as long as the data gets populated, I'm fine. So it's going to probably generate some, load some 6,000 plus rows into this table. So we'll see how much we get. This is awesome. So it's actually loading a lot of data. It seems to be done. So let's go ahead and commit the data. And now actually I'm going to select the data in this table, right? Just select all the data, and you will see that the data by default, or the data is actually sorted based on the primary key, which is product ID. And you can see, I haven't like specified any ordering. So this is the default ordering of data, right? And so basically your table data is sorted based on your clustered index, which is primary key over here, because you have the primary key in the table actually, right? So now the next thing is actually I'm going to create a similar table, which is which I'm going to call it products 2, but in this case I'm going to basically not define a primary key. I'm still going to have a unique key called, again, the same thing, it's ISBN. It's a unique key, and let's just give it a different name, just so we have kind of like we have different names for different constraints. So let's actually go ahead and create this table. And so this table is created. I'm going to copy the data from the first table that, where I loaded a lot of data. So I'm going to copy the data from that table into this table, right? So just very simple, and then I'm going to commit, right? So that's about 6455 number of rows inserted into this table. And I'm going to select all the rows from this table, and you can see that now the data is not sorted by product ID, rather it is sorted by this ISBN. It is sorting based on first character first, and then initially the first and second characters are the same, then 01, 02, and it keeps going, 05, and then 09, 0A, B, C, D, E, F, G, H, and then I think after the zeros you see 1. So it is basically sorting data based on ISBN. And why ISBN? Because of the absence of primary key, it's going to choose this ISBN column as it's going to choose this non-nullable unique index key, which is based on ISBN column, right? So it's sorting based on this. But this is actually a terrible idea, because if you're generating random alphanumeric string for ISBN, then you're not going to be generating the string in sort of like an ascending order or in any type of order actually. So in that case actually, when you're inserting data into this table, this B tree is going to be created behind the scenes, and then MySQL, like whatever program is creating or maintaining this data structure behind the scenes, has to work really hard to manage this B tree index actually, right? That's why this is a terrible idea to have like a UUID or some kind of alphanumeric string as a primary key actually. Or in the absence of primary key, well, MySQL is going to use this key for clustering, and again, it is very bad. So keep that in mind when you're creating tables actually, right? So finally, what I'm going to do is create another table called products 3, and before that I'm going to show you the output of this query, which is basically going to come up empty, or no rows returned. All I'm doing is actually checking whether this index, the index with name gen clust index, is there in this database actually, and then I'm checking the InnoDB tables and information schema. I'm joining InnoDB tables and InnoDB indexes, and I'm checking whether this index indeed exists, right? So it doesn't exist, which is why this query returned no rows. And I'm going to create this table, and this time I'm not even going to create a unique key, and I'm going to make all these columns as like nullable columns, So I just want to show you what happens when you have a scenario where you're creating a table with all nullable columns and no primary key index, no unique not nullable index, and and then I'm going to insert data into this table. Again, 6400 plus rows inserted, commit, and then I'm going to select from this product 3 table right now. And when the data comes up, you can see that there is still some ordering that's happening, and we don't have any of these options, primary key or a not nullable unique key available. Then how is MySQL able to sort data? What is it using? So it actually uses a hidden key, actually, right? A hidden primary key. So if you run the same query again, this query, you can see that this index has been created on products 3 table, which is maintained internally by MySQL for just the purpose of clustering this table, actually. Okay, so that's a lot of information. I hope you found this useful, and I will see you guys in my next video. Hello MySQL learners. So in this session I want to teach you the basics of using explain or explain plan in MySQL. Alright, so now let me just show you the table that I'm going to be working with. I'm going to be working with a table called products underscore 1, and it's got some product name, product type, price, and if the product is a book, it will have an ISBN number attached with it. And then there's a quantity column. So these are some basic columns that you would see in an e-commerce online store. So let's get started by just looking at the indexes of this table. So this basically has 2 indexes. One is a primary key index, which is on the product ID, and the other one is an index on the ISBN column, and this is a unique index actually. So let's get started by picking a simple query that we are going to kind of like optimize using explain. So the query that I'm going to be using is this. So I'm going to be selecting ISBN from this products underscore 1 table where product name has cat in it. So the product name is cat. Okay, so and before I run this query, I'm going to look at the explain plan of it, and I'm going to put a /g at the end so I get the output in a readable format. So first of all, it gives this output, right? And select is just one straight simple select. That's what this is showing. But the main thing is we are working with or this particular row is referring to this table, and apart from that, actually you have all these columns and then they're all null right now, like they don't make much sense apart from this. So this is a typed column, and all means that it is doing a full table scan. Basically MySQL is doing a full table scan. It's scanning the whole table. And how many rows is that? It's these many rows, and we are using a filter over here. It gets all those rows and then it filters the output, and basically there's about 600 rows with product name equals cat, right? So the filtered percentage is like 10% basically. and then there is some extra information. Let's go ahead and create an index on this table. Create index called, we can give an arbitrary name, and I'm going to create it on products 1 table, and the column is product name. Of course, this is the column on which I'm creating the index. Actually, let's just go ahead and run the explain again. So this is the explain plan, and that's how it looks. So basically you can see that again it's pretty much the same kind of output, but this time it is also showing some data for all these columns. So first of all, possible keys column shows like all the indexes that this query can use, and out of which, like, this is the key or index that it is it is going to use, this particular execution is going to use. And this is the key length in bytes, actually, right? The number of rows that is being scanned in this key, which is 589. And since this is index based, we're not really filtering data, rather we're just going to the index and getting the data, so there is no filtering over there. Let's actually create another index which also includes ISBN and see like what happens. Actually, I'm going to create the other index and give it a different name. So let's go ahead and run the explain plan again. So now again, the possible keys are these two indexes, but it still chooses to go with this particular index, and the index key length is the same, and then rows and etc etc. So there's no filtering that happened, right, because we're choosing an index. So you might be wondering, like, why it's not using the covering index, right? So this is supposed to be the covering index, and covering indexes are supposed to be better than normal non-clustered index or a secondary index. So you can actually like use a format like JSON format to get more information. So how you can do that is by just specifying like format equals JSON, and use that, and so that's going to give you the output in JSON format. And you can see that it gives you a little bit more information, as in like the query cost. This is how much it's going to cost for MySQL to execute this query, and this is a representation of the amount of work MySQL has to do to run this query actually. So the cost for this one is 76.90, right? And then again it says these are the possible keys, and used key parts is product name, which was not given over here. And then there's a cost info, which is a split of where the cost is going. So you can read MySQL documentation on all these fields. You might be wondering why the covering index is not being used, and we can actually force that index by using this use index syntax, or use index keyword, and then I'm going to put the index name that I want to force, which is this one. And when I run the explain plan this time, it shows the cost of this one is going to be 109.27, in comparison to the previous explain plan where the cost is only 76. And this is why MySQL is going with this particular plan instead of this guy. Okay, I hope this session was useful.